This is how can I use the Pythagorean theorem instead of
How do you say that?
Pythagorean instead of the distance formula. I did lock the door. Go check it. Okay, I'm going to show you, or I'm going to show you the distance formula. Distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That formula will give you the distance between 2 points. Obviously, if you know the coordinates of the 2 points. So if you had a segment and it's on the coordinate plane or not on, it doesn't have to be on the coordinate plane. You just have to know the endpoints. And let's say that this one endpoint is at 3, 8. And this endpoint is at, I don't know, -2, -4. Now, we talked about the subscript yesterday. This means the x value at the second point minus the x value at the first point. Agreed? Y value at the second point minus y value at the first point. In the past, it's been very helpful when students label these points first. Meaning, you can call the points point 1 or point 2. It doesn't matter which one you choose as point 1 or point 2. You just have to stay with point 1 as point 1 throughout the problem. So the hardest example is when the second point has negatives in it. So we're going to do that one. We're going to call this number 1. And this one's number 2. So that makes this 3, 8 x sub 1 and y sub 1. And at point 2, this is your x sub 2 and y sub 2. And now that you've taken the extra 4 seconds to do that work, the problem is a matter of replacing letters with numbers and typing it into the calculator. Okay? So look, the distance between these 2 points is going to be equal to the square root of x sub 2, -2, minus x sub 1, which is 3. And it's got to get squared. And we're going to add it to y sub 2, -4, minus 3. And it's got to get squared. And I actually... It's -8, like I said. And actually, I did the easier of the examples, didn't I? I should have done it where you're subtracting a negative.
We could probably figure it out.
Hopefully you can, since it's a... Yeah, if you can't, I'm sorry. Alright, so look, now just on -2 minus 3, that's going to be -5 squared plus -4 minus 8, -12 squared. That's going to be the square root of 25 plus 144, which is going to equal the square root of 169. In your calculator, the square root button is 2 above the 9. So that's going to be 169 square root, and that equals 13. So the distance from the distance or the length of this segment is 13 units. Yes?
Do those squiggly lines mean anything, or that's just your equal sign?
Squiggly lines mean approximately.
Uh,
Okay, and when you'll see them is when you're square rooting and the number under the radical is not a perfect square. In this case, it shouldn't be squiggly lines because the square root of 169 is exactly 13.
okay.
Where you'll see it is if in your calculator type 24 square root button, 2 above the 9. If you did the square root of 24 in your calculator, that's not a perfect square. And the square root of it is 4.9, and that's an approximation. That's what that means. The squiggly equal sign means approximately.
Alright.
You've rounded something.
Okay.
Alright, so everybody's okay with the distance formula. Now, I'm going to show you how to use the Pythagorean Theorem to do the same problem. And most of you will think it is much simpler. The Pythagorean Theorem states that for every right triangle a squared plus b squared equals c squared, where a and b are the legs. The legs of a triangle. That's the two sides that aren't the hypotenuse.
What?
In a right triangle, it's got three sides. It's a triangle. If it's a right triangle, it's got 190-degree angle. The sides that make up the 90-degree angle, those are called legs. And those are always sides A and B. The side opposite the 90-degree angle is always side C, and it's the hypotenuse. In every right triangle, well, unless it's rotated, but I mean for today and tomorrow and Friday, every right triangle that you deal with is going to have a vertical leg and a horizontal leg. Okay? The one that's on the angle, the one that's across from the 90, is always the hypotenuse. So, here's how this works. Is everybody caught up? Alright, so we're going to do the same problem that we just did, but we're going to use the Pythagorean Theorem instead of the distance formula. So, what were those coordinates again, please? 3, 8, and? Say again? Okay. You see this picture? Okay, now, if I take a line and I go from the point in the upper right and I drop it down vertically till I am horizontal from the other point and stop. Agreed? And then if I go from the second point to the right horizontally to where I meet the vertical leg, what did I just form?
A left triangle.
No, I just formed a right triangle.
But it goes to
Stop
the
it.
left.
I just formed a right triangle. And I know now that if this is a right triangle, that a squared plus b squared is equal to c squared. And I know that the side opposite the 90-degree angle is c, which means the other two are a and b. Now watch, this ties into what you did yesterday. The vertical leg of this triangle. On the coordinate plane, which axis is vertical? X or Y? The y-axis is vertical. So don't the y values tell you the length of that leg? Aren't you going from 8 to negative 4? How far is that? 12. This leg is 12. On the coordinate plane, the horizontal axis is the x-axis. Look at your change in x values. You go from negative 2 to 3. How far is that? That's 5 units. That side of the triangle is 5 units long. You with me? The vertical leg is the difference in your y values. Okay, the difference between 8 and negative 4 is 12. The distance or the length of the horizontal leg is the difference in the x values. From 3 to negative 2 is 5 units.
Would that be the step 2 in the distance?
The steps don't coincide Pythagorean Theorem to distance formula, because when you get good at this, you're going to do probably 2 steps to find the distance between 2 points. Because watch, according to the Pythagorean Theorem, 5 squared plus 12 squared equals c squared. Right? So that means that 25 plus 144 equals c squared. So 169 equals c squared. Now, if 169 is equal to c squared, to find the value of c, you find the square root of each side of this equation. You already know that the square root of 169 is 13, and the square root of c squared is c. So there's the distance from point 1 to point 2. And what will happen is, as you get better at this, this will become your first step. Okay? You'll say that, okay, the horizontal leg is 5, and 5 squared is 25. The vertical leg is 12 squared is 144. And I saw some people last year, they were doing distance formula problems in their head all year long. They just got that good at it. Okay? There's fewer steps, which means there's less chance to make a mistake. All right? And in this class, you use the Pythagorean Theorem all year long. So you might as well get really good at it. And you can convert every distance problem into Pythagorean Theorem, whether it's longitude, latitude, or whether it's on the coordinate plane. It's the same concept. Got it? All right, your practice for today is on page, it's going to start on page 47, 8 through 10. And then it continues on the next page, 18 through 20. All right, and it's like 6 problems. The bell rings in a couple of minutes, but you should be able to finish this before you leave. Oh, no, yeah, you got till 36. You got plenty of time. Check headline for homework.